Hello everyone. So we're going to talk about the ozone layer and the indoor pollutants in this video. So ozone is a highly beneficial gas in the stratosphere. It shields the Earth from UV light. Um, and scientists discovered that our human-made chemicals, um, ozone depleting substances were causing degradation of the ozone layer, and it caused like a hole in the layer. So the main substances are called halocarbons, and these are when the hydrogen atoms are replaced by chlorine, fluorine, or bromine. And there's one specific class as chlorofluorocarbons, CFCs. And we use these in fire extinguishers and propellants for spray cans and cleaners for electronics. So these are human-made, and these are destroying the ozone. And these are very non-reactive, and they were assumed that they were safe, but they are not. And when these are broken down with a UV light, and these are broken down into chlorine and carbon atoms, and that can split the ozone molecules. This the chemical reactions kind of showing you that. You don't have to know this, but I just wanted to show you that. So you don't have to know this chemical reaction. So they discovered that there was a hole in the ozone called the ozone hole, and it's was forming every spring over Antarctica. And it was so basically they wanted to do something about that because that's not safe because ozone layer is pretty much stopping the UV to reach the sun, the Earth. So this ozone hole was, it's alarming. It was alarming. So what they did was this Montreal Protocol. So the policymakers, they responded to this concern and they kind of came together and they did this protocol and they said, oh, every nation, they agreed to cut CFC production by half by a certain year. I think 1998. Yeah. So additional agreements were passed and they said, oh, we're gonna work on this. We're gonna reduce this in half by 1998. So these are the emissions, and this is kind of showing you no protocol, and then Montreal Protocol, London, and then other things. So phasing out and replacing these chemicals destabilizes ozone hole, and it's supposed to repair itself by 2080, or fully repair sometimes after, sorry, not 2080, sorry, 2060. So this is Montreal Protocol, and after that, you can kind of see it's um, um, been kind of going up and down actually. All right, so acid precipitation also mobilizes toxic metals, um, and acid deposition often takes place by acid rain, and it's the deposition of acid or acid-forming pollutants from atmosphere on the Earth's surface, and then acid rain or fog or gases or deposition of dry particles. So acid deposition is one of the atmospheric deposition which happens with any solid or liquid material from the atmosphere that's dropped onto Earth. So atmosphere deposition is a term that refers to a wet or dry deposition of a variety of pollutants that includes mercury, nitrates, and others. And acid deposition originates primarily with the emission of sulfur dioxide and nitrogen oxide. That happens, through fossil fuels that we're burning. So nitric oxide and sulfur dioxide. And when it reacts with water and oxygen, then it becomes sulfuric acid and nitric acid, and that's the acid deposition. And then suspended in the troposphere, droplets of these acids can travel days or weeks or hundreds of kilometers. So it's basically low pH that makes the acid. So acid precipitation, it has a lot of, effects. It elevates soil concentration of metal ions, and it can damage the roots of the plants. It can impact the nutrients in water. And in some areas, acid fog with a pH of like 2 um, can stay for a long time. And if it's acid fog is covering the trees, it can kill the trees. Animals are affected by this too. Population of snails decline usually, and this reduces food supply for birds. So it's pretty much affecting, all the ecosystem. And if the acidic water runs off from land, it affects the streams, rivers, lakes. Thousands of lakes have lost their fish because of acid rain. So, and that's due to not just the pH, but also the ne- acid neutralizing capacity of soil, rock, and water. They receive the acidic input. So that's going to alter the ecosystem, and that's going to damage the crops, buildings. This is kind of showing you that this uh, before acid damage, it has corroded the building or corroded this structure here, stone building, after acid rain damage. So we are addressing this. We have put some restrictions on the emissions, which significantly reduced the nitrogen deposition. And EPA controls this, the Environmental Protection Agency, and overall the pH of participation has improved over time. So this is kind of showing you this was really half of it was red in 1990 and this is in 2017. So we have tried controlling it. Moving on to indoor quality, air quality, you might think that it's safe to be inside, but there are a lot of things that are causing indoor air pollution. And there's some things we can do to limit that. For example, limiting ventilation, installing windows that do not open, worsening that has worsened the indoor air pollution if there's, air that's not crossing. So what are some things that are contributing to the indoor pollution? Um, so if, people, they don't have sometimes, especially in India, people have still wood burning stove. They're using animal dung or crop waste inside the homes, cooking for cooking and heating with little or no ventilation. So in the air of such homes, concentrations of the PM matter or particulate matter, they pass the EPA standard or they're higher than that. So people inhale these dangerous amounts of soot, carbon monoxide, and other pollutants on daily basis. Smoking cigarettes also contributes to that. It irritates the eyes, nose, throat while worsening asthma and increasing risk of cancer and lung disease. E-cigarettes, they also have these organic compounds that and heavy metals in them. We talked about radon before. So that's a gas that's colorless and it's hard to detect without a specialized kit. And that also contributes to the indoor pollution. So it's kind of showing you the area that's highly impacted versus low. The yellow is low. So many walks pollute indoor air. So in our daily lives at home, we're exposed to many indoor pollutants, and these walks, these airborne carbon-containing compounds, they're released by plastics that we use, oils, perfumes, paints, cleaning fluids. You're cleaning your house with these cleaning fluids, adhesives, pesticides if you are gardening in your backyard and using pesticides. So they evaporate from furnishings, building material, carpets, laser printers, sheets of paper. So these are that's just picture that's showing you pesticides, rocks and soil beneath the house, computer and office equipment. So look at this how like there's a lot of things that are creating the indoor pollution. So um even though we are surrounded by products that emit box, they're generally released in very small quantities unless you're doing something continuously that's increasing the amount indoors and if you're opening your windows, I think that kind of crosses the air and kind of helps out a bit. Living organisms can also pollute. So tiny dust mites can worsen asthma and cause allergies. Um, and pets they carry a lot of these things. Fungi, mold, mildew spores can cause allergies, asthma, and other respiratory problems. Airborne bacteria can cause disease. Viruses can cause disease. Heating and cooling system in a building make good grounds for microbes, provide moisture and dust. And microbes, they can also cause something called sick building syndrome. So this is illness caused by unknown microbe, that's called sick building syndrome. So maybe you have mystery symptoms, you know what's causing it. So the sick building syndrome. All right, so what can we do to enhance the indoor air quality? So we can start using low toxicity material, monitoring air quality, keep rooms clean. We can get one of those air purifiers that cleans air. Drying wood before burning it, cooking outdoors, shifting to less polluted fuels such as natural gas, installing hoods, chimneys, cooking windows to increase ventilation. And residents of developed countries can reduce the exposure by not smoking, testing for radon and mold spores, and minimizing exposure to walks. So, you know, and we can try to even use a clean power for cooking, like solar and heating and lighting, because newer fuels and technologies are more expensive than traditional biomass, but often helpful. So that might be better for our health. It can give us better quality of life, maybe even increase our lifespan.